Okay, so in this video I'm going to go through questions 14 and 15. Okay, they're both similar in terms of the actual equation that you're given at the start. So question 14, a curve has this equation, and what you should notice there straight away is that you've got a function x cubed minus 2x times another function, so you're going to have to use the product rule there. Find f dash of x. Okay, well, if we've got the f of x is x cubed minus 2x times e to the minus x, that's going to be u and that's going to be v. So du is going to be 3x squared minus 2, and dv is going to be minus e to the minus x. Okay, so u dv will be minus e to the minus x times x cubed minus 2x plus v du okay, and effectively that's it, that's your answer. What I'm going to do is just tidy it up a little bit by taking out e to the minus x at the front. That means that I'll be left with here minus this bracket, which is minus x cubed plus 2x, and if I take that, factorise that out, I'll just be left with this bracket plus 3x squared minus 2, which means that'll give me e to the minus x brackets minus x cubed plus 3x squared plus 2x minus 2. Okay, so that's part A. You're done at that point, by the way, then. If you can get to there, you're fine. Part B says the normal to C at the origin intersects the curve again at P. Show that the x coordinates of P is the solution to that equation. Now, the normal at the origin. So what that means is we're going to sub in 0. It means we've got a coordinate here, haven't we, of 0, 0. So we're going to sub in 0 to this. So we're going to do f dash of 0. This is going to give us our gradient of the tangent at the origin. Now that will be e to the minus 0, which is going to be 1, isn't it? Minus 0 cubed plus 3 times 0 squared plus 2 times 0 minus 2. That means that's all going to give us 1 times, that's going to go, that's going to go, that's going to go, minus 2. So the gradient of the tangent at the origin is going to be minus 2, which means the gradient of the normal will be positive a half. And because we're using this at the origin, we're going to be using that with the coordinate 0, 0. So if you think about this a lot, you can use y minus y1 equals mx minus x1 here, by the way, but just to save a little bit of time, if the gradient is a half and it goes through the origin, the equation is just y equals a half x. Okay, so that is the equation of the normal at the origin, and I want to know when that meets the original equation again. So what I do is I set that equal to the original equation. I'm going to run out of space here, so I'm going to do this over here. So I'm going to say that a half x equals x cubed minus 2x e to the minus x. Now remember, e to the minus x means that this is a half x equals x cubed minus 2x over e to the minus x. Sorry, over e to the x, apologies, minus shouldn't be there. Call it, change it into a plus then. So what I'm going to do is I'm going to cancel out x's. I'm then going to put that e up there, which is going to give me half e to the x equals x squared minus 2. I'm now going to cancel the half by doubling everything, so I'm going to get e to the x will equal 2x squared minus 4, and then given what I'm trying to get to, I can see that if I just bring the minus 4 over to the side, so we get e to the x plus 4 equals 2x squared. We've shown that we end up with this equation here. Okay, so question 15, ignore question 16 there, by the way. I had to chop this thing out as a rectangle, so that's why that's popped up. Ignore that, I just want you to do this. So question 15, very, very similar to start off with. You've got this equation and you want f dash of x. So what I would do first, part A, multiply that out and then do what we did there. Okay, because it's going to be product rule again, isn't it? But here, because you've effectively got three things being times together, haven't you? You've got the x, the 1 plus x, and then the log x. But you can multiply these first two things together. So the way I'd write that is x plus x squared log x, and then do your u and v. Okay? So you're going to use the product rule the same way that we did on question 14 to get f dash of x. Once you've got that, it's then saying, hence show that the x coordinate of a, which is a minimum, is given by the solution to the equation this. If we are looking at the minimum point on the curve, remember that means that f dash of x will equal 0. So set it equal to 0, and then you're going to have to do a little bit of manipulation with logs and e's and things like that. Okay, so pause the video, have a go at that, and then when you're ready, come back and we'll go through it together. So hopefully here what you add is that du will be 1 plus 2x, and that dv was 1 over x. So in terms of our differential then, u dv, I'm going to multiply this out and simplify it at once. Okay, I'm doing this bracket times this. X times 1 over x is just going to give me 1, isn't it? In fact, you know what, I'll just write it out. u dv is x plus x squared times 1 over x plus v du log x times 1 plus 2x. Okay, there it is all written out. Simplifying that, divide both of these things by x to get rid of this thing. It's going to be 1 plus x plus 1 plus 2x log x. Okay, so that's your differential. For part B, it's saying that we want the x coordinate of this thing, which is a turning point. So at that point, dy by dx, or f dash of x, will equal 0. So set this equal to 0. And we want to show that it ends up being x equals e to a power. That means that I want to raise the logs, which means that I want to isolate this thing first. So what I'm going to do is bring these over here. So I'm going to turn that into minus 1 minus x equals 1 plus 2x log x. Divide by this bracket, so we're going to get minus 1 minus x over 1 plus 2x equals log x. And then if you look there, it's minus, this thing says e to the minus 1 plus x over 1 plus 2x. Now if you compare that to what we've got here as our fraction, when we raise logs here, that's going to give me x on that side, and this is going to give me e with a power, and it's going to e to the power of this. Now if you look there, what they've done is basically just put that minus outside of this and put that in a bracket as 1 plus x. So minus 1 plus x on the top of the fraction and 1 plus 2x on the bottom of the fraction. We're done. Okay, so just a little bit of manipulation there to do with logs and things like that. Well done if you got that one right. It was a little bit fiddly. Well done.